This is an introduction to TikZ and PGFPlots, two LaTeX packages that are going to help you draw figures and illustrations inside your LaTeX document. The primary goal of using LaTeX is to ensure consistency inside your document, and TikZ and PGFPlots ensures that the figures that you include inside your LaTeX document are also going to be consistent with the content that you have inside. This means that your font styles, your colors, your mathematical expressions, and the symbols that you use inside are going to be consistent with the figures and the text labels that you use too. I'll be covering some of the basic commands that we can use to draw illustrations inside TikZ and add plots using the PGFPlots package. However, most of the time you are going to have to use the documentation to figure out some of the really nuanced commands and options that TikZ provides. For this, I have two resources for you. One is tikz.dev, the website, and the other is the PDF manual of the PGFPlots package, which also has commands and options relating to the TikZ package. Here's an example of an image that was created using TikZ. So in this case, you can see how the coloring and the font size and styles are consistent with the content inside the LaTeX document. Here's another example. In this case, you can see how the symbol E theta cap inside the diagram and in the content is of the same font style. Here's yet another diagram that was drawn using TikZ, but this was created using a more advanced package called TikZ 3D, which allows you to draw three-dimensional illustrations too. But the fundamental commands that you're going to use are going to be the same. Let's go ahead and dive right into TikZ. I'll start with a blank document here. And the first thing that you need to do is import the TikZ package. So I'll do that using use package, and TikZ is the name of the package. Some people pronounce this as TikZ2. That's also right. Every time you need to add a TikZ illustration or a figure, you need to start with an environment called TikZ picture. So I'll go ahead and create that. Any command that you add inside the TikZ picture environment, LaTeX recognizes that as a TikZ command. Fundamentally, there are two basic commands that you are required to know to draw almost all of your diagrams, and those are the draw command and the node command. The draw command helps you draw lines, curves, shapes, and similar constructions using line segments or curves. On the other hand, the node command helps you add text into your illustrations. We'll talk about the node command a bit later. Let's start with the draw command. Unlike graphical interface based image illustration programs that you might have used, TikZ does not have the provision, because it's a script based language, to say let's start a point from this specific point, or let's start a line segment from this specific location, or let's end a line segment at that location, and so on. Instead, we talk to TikZ in terms of coordinates. The basic coordinate system that you can think of with which you can work inside TikZ is a Cartesian coordinate system, where the horizontal axis is the x-axis in the rightward direction, so that's positive rightwards, and in the vertical direction you have the y-axis, and that's positive upwards. So let's try drawing a line segment that extends from 0, 0 So 0, 0 to say 3, 2. So that's two coordinates that I've input to the draw command, and to inform TikZ that I'd like to connect those coordinates using a straight line, I use the symbols dash dash. Let's go ahead and compile those. And there you go. You have a line segment inside your document that extends from 0, 0 to 3 units to the right and 2 units in the upward direction. That's the point 3, 2. You can also chain these line segments with other coordinates, say 1, 3 perhaps. And there you go. You have a polyline or a multi-line. Now you might be wondering, what are the units I'm using over here? The default unit inside TikZ is in centimeters. I can change this by saying x equals, say, 1 inch and y equals 1 inch. So these are options that I'm passing to the TikZ picture environment, and these inform TikZ that I'd like a scale of 1 inch in the x direction and 1 inch in the y direction. So 3 is going to be interpreted as 3 times 1 inch, and 2 is going to be interpreted as 2 times 1 inch. Let's see how that changes our figure. So that scales up our figure. You can also change individual units or scaling for each of the directions, and that will scale and skew your image accordingly. I tend to stick with the defaults usually, and if I require to increase the scale of my diagram, I simply change it using the option scale. So in this case, I'm scaling it up by 50%. And there you go. Let's keep that to its default right now. I can pass in different options to the draw command which change the style of the line segments that I use. For example, if I would like to change the color, I can simply specify the color. I can change the type of line that's being used. And I can also change the thickness of the line. There are a couple of keywords that you can use. I think there is an ultra thick too. And this allows us to draw all sorts of different line segments and line styles. You can also create an arrow. So that's dash greater than. And what this does is include an arrowhead to the end of your line segment. And that can be done in both directions. So you can say lesser than and dash, which means the arrowhead is in the other direction. It's in the start point. Let's keep that a thick line. Let's say I wanted to use some sort of an offset based dimensioning rather than the global coordinate system that we have here. So in this case, it goes from 0, 0, 3, 2, and 1, 3. Let's say I wanted to draw a line segment 2 units to the right of this point. In that case, I'm taking 1, 3 as a reference point, and I would like to move the next coordinate to the location 2 to the right and 0 to the vertical 0 in the vertical direction. For that, I can use the plus symbol. So this tells TikZ that you want to offset it with the previous coordinate that you've input. Let's take all of these off. and just work with this. Now if you wanted to chain these coordinates, you would have to do something like this. Let's try inputting 0 in the x direction and 3 units in the vertical direction. So I would like that to be an offset, and you'd expect this to be somewhere over here. So that's 0 in the x horizontal direction and 3 units in the vertical direction. So you'd expect that to be over here. Let's see what happens. Now it's not there, but it seems to have referenced the previous point. And this is one of the nuances of the single plus symbol. And if you'd like to update the reference with which you're offsetting your coordinate, you have to add another plus symbol. So this ensures that 0, 3 is being referenced with the previous coordinate and not the coordinate before that. So instead of saying 0, 3, so that's 3 units in the vertical direction, with respect to this coordinate, I am now saying update the reference to the latest one, so that's this point, and then go upwards 3 units in the vertical direction. So it's always just easier to use the plus symbol rather than work with the single plus symbol. I typically just use the plus to draw offsets like this. You can also use a polar coordinate system. So let me take all of this off and say I'd like to draw a line segment that starts from 0, 0 and then ends at 50 degrees from the x-axis with a distance of 2. Let's see what that looks like. And the format for that is 50:2. So theta colon r. Mathematically, this would be written as r comma theta. But in our case, inside TikZ, we write that as theta colon r. So that's 50 degrees from the horizontal, that's the x-axis, and then 2 units in that 50-degree direction. You can also change this to say negative. So that's negative theta. And anything that you do in the Cartesian coordinate system also applies here. So you can say, let's do an offset at 0 degrees. So that's the horizontal direction, and a unit of 3 units maybe. So this ensures that I'm not referencing with respect to 0. Instead, I'm using this reference point to offset it towards the right. All right. You can also draw curves using the draw command, in which case you use the keyword to. Let's start with just that, and you can see how it joins the coordinates 0, 0 to 2, 3. If you were to pass options, say something called out to the to keyword, this means that you'd like the line segment to come out of that starting point at an angle of 0 degrees. So that's going to mean that the line segment starts and comes out at in a horizontal manner, and then it's going to join the 2, 3 coordinate. Let's see what that looks like. So now you can see how it comes out at 0 degrees and then joins at some arbitrary angle. We could make this say 180 degrees, and for that you can use the keyword in the option and pass it to the to keyword. So let's do 180 degrees. So that comes out at 0 and then joins at 180 degrees. 180 degrees is counted from the positive x-axis, so that's 0, 90 in the upward direction, and 180 in the leftward direction. And this can be any angle, so you could say negative 60, and we'll see what happens. So that's the 0 degrees, and that's 90 degrees, and that's negative 60. You can also draw shapes using TikZ. So let's take that out and say I want to add a rectangle between the points 0, 0 and 2, 3. So this means that the lowest right corner, the lower right corner of the rectangle is going to be at 0, 0, and the upper right corner, sorry, the lower left corner is going to be at 0, 0, and the upper right corner is going to be at 2, 3, and it'll join a rectangle. It'll draw a rectangle using the line segments. You can also do circles. So let's say 0, 0, and I require a circle with a radius of 0.5 centimeters maybe. And there you go. I can also reference this coordinate as an offset. So I'll do a plus there, but it will not make a difference because it's referenced with respect to the origin 0, 0. Notice that I keep having to type 0, 0, 0, 0 everywhere that I want to use that coordinate. Instead of this, I could simply give a label to that coordinate 0, 0 using the coordinate command. I'll give it the label origin or ORIG and say it's located at 0, 0. Now everywhere that I require to use that coordinate 0, 0, I can simply say ORIG. If I were to compile it, there wouldn't be any difference because it's the same thing. Let's add another line over here extending from 0, 0, this time referenced as 0, 0 instead of ORIG, all the way up to 0, 3. And let's color that red. I'm guessing that's going to be overlapping the blue line. So let's change that a bit and shift that to the -1 location. And there you go. You have the red line there. Now, if you'd like to change the location of this figure, the rectangle and the circle, you can simply change the coordinates in this label, in the coordinate command here. So let's shift it upwards by 1. And let's shift it downward by -2. Sorry, that's to the left. So let's shift it to the left by 1 and downward by 2. So 1, -2. And there you go. You have that coordinate. Move the figure wherever you want. This happens, and this is only possible because you used an offset over here. If you were to use 2, 3 here, that would refer to the actual global coordinate 2, 3, and that will change the size of your images or skew it in undesired manner. So it's always better to use these offsets and kind of parameterize your drawing. All right, let's take all that off and let's look at something called projections. Assume I have a coordinate A at some location. Let's use 0, 0, and another coordinate B at 2, 3. Let's draw a line that joins these two coordinates. Let's also have a coordinate C at 2, 0. Let's add a circle there so that you can visualize the coordinate C with respect to the line AB. So at C, let's draw a circle. Let's put 0.2 mm as its radius because I just want a small marker there. And there you go. Let's make that slightly larger. Let's also add a fill to that. And there you have a point. Assume that I wanted to do something like joining the point, the coordinate C, to some point on the line AB. Now I could do a mathematical calculation and figure it out. Or instead, I could use the TikZ library, calc. You import a TikZ library by using the command use TikZ library. And in this case, the library that we require is calc. And what we're trying to do is to compute a coordinate D that lies on AB, which we have no idea right now. And I'd like to draw a line that joins C to D. Calc allows us to perform calculations using the coordinates that we provide to TikZ. And we do this using mathematical kind of expression manner, using mathematical expressions, but we put them inside these dollar signs and say, for example, I could do something along the lines of b plus 1, 2 if I require. So that means take the coordinate b and add 1 to the x coordinate and 2 to the y coordinate. So that shifts it over there. I could also do something like this. Where I say I have the line AB and I want the coordinate D to be midway, so that's the 0.5, between the line AB, or between the coordinates AB. And this allows you to figure out a point on that line joining the coordinates A and B at how much ever location that you want. So you could say 0.25 for quarter the length, or any value, any fraction between 0 and 1. You can also use absolute lengths. So that allows you to draw a line joining C to D, where D is 2 mm from the coordinate A. You can also draw the perpendicular from C to A to the line AB using this notation. So that's a perpendicular line, and AB is perpendicular to CD. One other library that I frequently make use of is the arrows library. This library allows me to change the arrowhead. So I'll give a quick demonstration of that too. So we had the original arrowhead here, and that's the point there. Let me zoom in on that a bit. If I require to use a different arrowhead, I can use the arrowhead name. In this case, it's called Stealth. So that's a more popular arrow. There's also one called LaTeX. And the more recent version of the arrows library is called arrows.meta. So I tend to use this specific library than the arrows library. And this gives me the option to use a much more flexible arrowhead called LaTeX, but with a capital L. And this allows me to change the size of the arrowheads too. So this is just a more convenient library that I typically tend to use. We have now looked at how to draw line segments, curves, and shapes using the TikZ draw command. Now let's take a look at how to draw or how to add text labels to our figures and illustrations. Let's take the same example and add in labels for the coordinates in our figure. So this is A, and for that we use the node command. So let me add a new section over here, separated by a little label, a comment. And I use the node command to say label A. So this is just a label for my node, and I say that's located at the coordinate A, which happens to be 0, 0, and I'd like to say A. Let's see what happens. So TikZ adds the text inside the brace to that location given by the coordinate A or 0, 0. I can also make this a larger text if I require it. And it drops in exactly at that location. You will also note that the node is positioned so that the center of the text coincides with that coordinate that you've input inside the node command. This is not usually desirable, and you can change the location, change the positioning using the keywords above, below, right, or left. So let's place the text label below that point. For that, I pass in the keyword below to the options of the command node. And there you go. It shifts below. I can also pass below left so that it shifts to the left. Let's keep that to be A. Now, oftentimes you might require to label a vector, for example, or just a long line segment that you have drawn using the draw command. And in this case, assume that I have this vector pointing from this coordinate C to some point, some location, and I'd like to add a label to that vector along that line, which says, for example, vector tau. And for that, you insert a node, but not separately. Instead, you insert it on that line during the draw command itself. So in this case, I am drawing this vector or this directed line using this command. So I insert a node over here, right after the dash dash. So I say node. Note that I don't have a backslash here, and it's just a plain word, node, and no options for now. I don't have a specific location, and I simply say tau. Let's say vector tau. Let's see what that gives us. So that inserts tau to the midpoint of that line segment. I can change the location of tau using the command, using the keyword POS passed as an option to the node keyword or node command. Let's say 0.25. So that positions the tau symbol that I've input at 0.25 times the length of that line segment. Usually you do not want it intersecting the line, so I could use the same concepts that we used in this A node that we inserted, and that positions the above keyword positions the label above that line segment. Typically you'd also like it to be in the same orientation as the line, and for that you can say sloped. And there you go. Now the advantage to doing this is that all of this is in a parametric form, which means one is referenced to another. So this means you can change things and everything is going to just work out in a nice manner. For example, let's say 0.75 over here, which means that I'd like this point D, the coordinate D, to be 3/4 from A towards B. And let's see how the diagram changes. So you can see how the tau symbol that I've added to this line still stays in the same orientation as the line, and also in the same location, same relative location with respect to the length. So this is a super useful feature, and you can use that for a lot of engineering drawings, especially things like free body diagrams or just general illustrations of multiple vectors in a point or things like that. As a final demonstration of the node commands features, let's try drawing a flowchart kind of structure using the node command. So I'll take all of these off and say I have a node A at the location 0, 0 with some text inside, probably something like start. Let's say I have another node too, node B at 3, -4 that says stop. Let's go ahead and compile that, and there you go. You have the two text labels added. You can draw the boundaries of the node using the draw option that you pass to the node command, and you've got the rectangles. You can make these rounded rectangles if you require them. Rounded corners is the right keyword there. Yeah. So you can pass rounded corners. You can also pass a circle, which makes the node boundary a circle. You can change the size of the circle by changing the separation between the text and the boundary of the node. In this case, you can say inner separation, which is inner sep, equals 2 centimeters maybe. And that will change the size of the node. Let's keep it at the defaults. And let's say I wanted to draw a line that starts from the start box to the stop box, or the start node to the stop node. We'll use the draw command again and say the same thing that we used for joining two coordinates. But now note that the line does not intersect the boundary of the node, and instead just gets cut off at the boundary, but it also ends up at the center location of that node. You can also do arrows over here, and you can also change the start and end positions of this line segment that joins these two nodes using relative positioning of the node itself. So if you wanted to say start the arrow at the bottom midpoint of this node, you could say a dot south, and if you want it to join at the topmost midpoint location, you can say b dot north. You can also do things like southeast to northwest. Note the space between these two words. This also allows you to change the location of the nodes. So if you were to say +4 over here, that changes the location of the nodes, but that also changes the start and end points of your arrowhead. Sorry, the arrow. One other library that I've used during drawing of flowcharts is the positioning library. So that's positioning, and what this allows you to do is, instead of saying I want my node at a specific coordinate in space, I can simply say I want it below another node. So I can say below of A over here, let me take all of this aside. So I'll just clear all of this. And let's try running that. I'm guessing it does not require the at keyword. Yep, that's it. So instead of saying at 0, 0 or some other coordinate, you can simply specify this option over here, and that means you can chain different nodes. So let's do something like that and say I want this below of A and I want this below of C. I've missed out a semicolon here, and that's given me a warning or an error. So I'd like to join A and C and C and B. So that gives me something like a flowchart. Now I can change the distance between these nodes using node distance. Let's make that 2 centimeters. And you can use this to consistently specify the distance between elements inside a flowchart. And with that, we come to the end of the draw and node commands demonstration. We'll move on to the PGFPlots package and take some time to set up a very simple plot inside LaTeX using the PGFPlots command. PGFPlots package. Now I have here a blank slate with just a TikZ picture environment and the TikZ package. Let's go ahead and import the PGFPlots package. And let's also begin a new environment called Axis. This allows us to draw plots inside inside the LaTeX document. The command that's important here is the add plot command, and let's simply draw x squared. Similar to TikZ, you are going to see that you need to end your commands with a semicolon. You'll also notice that PGFPlots very rapidly has created a very beautiful plot. So it's got an x-axis, it's got a y-axis, and all of these are automatically taken care of. The ranges of all these are set, the font styling is set, and you can see markers on the plot. Another thing that you'd notice is this warning that has come up. So it says, consider writing PGFplot set compat equals 1.18. This ensures that you're using the specific version 1.18, and you can simply say the same. So PGFplots set compat equals 1.18, and that should suppress that warning, and the warning should not appear. If you would like to just use the latest version, you can simply say newest, and that should work. Coming back to the plot, you can pass in the same options that you used inside the draw command inside TikZ to the add plot command too. So for example, you can make this thick, you can make this a red line, and you can change the type of marker that's being used using the mark option. So let's say I wanted to use O's or unfilled circles, or perhaps I would like squares, or maybe I'd like them to be filled. And for filled squares, I simply say square star. The star signifies the fill color being added to the marker. I can also change the domain that I'd like my curve to be drawn in. So in this case, let's say I only wanted the positive x-axis. So let's say 0 to 10. And automatically TikZ takes care of the axis labels and dimensions of the plot too. Let's also try changing the width of the plot. Let's make that 90 mm by a height of 50 mm. So that automatically resizes your plot and ensures that all your labels are also marked in a consistent, neat manner. So all of this is automatically taken care of by PGFPlots. You can add legend. You can add a legend to your plot. So let's say add legend entry, and we'll call this curve y equals x squared. Let's see what that gives us. So you have a legend that's been inserted to the northeast location by default. You can change the position of your legend using the command, using the keyword legend pos equals, say I wanted to change it to the northwest location, and you can do that, and it automatically takes care of the spacing between your legend and your axis. All of these are also customizable, but I typically go for the defaults, and that's pretty much what I tend to stick to because they're pretty neat and clean. They result in really nice plots too. You can also add, let's say, an X label. So in this case, let's say I wanted to do, I wanted to add time as my X label and my Y label to be temperature maybe. And TikZ adds in those labels. You can also add mathematical expressions just like in LaTeX. So you have T of T as a mathematical expression, and let's also add a different curve perhaps. So I'll just copy paste that. Let's say I wanted to plot y equals x alongside 2, and let's make that in blue without any marks. So that's a solid line, and there you go. Perhaps you require a grid in your plot, so you can add grid. And these are super simple curves. They are math expressions. However, many a time what you'd require is tabulated data, plotting of tabulated data, and for that you have the keyword table. What this allows us to do is to add a header and also corresponding data points. So let's say 0, 0 and 4, 40, 8, 60 perhaps. Let's see what that gives us. So you have the 3 data points that I've added. Let's add 1 for completeness. I can change the style of the plotting. Say I want it in black and without a solid line joining those points, so only marks. And there you go. You have your tabulated data too. Note that the header I have used as X and Y. I can use time and some other custom header too. In this case it's temperature. And PGFPlots automatically takes the first 2 columns. You can have multiple columns here too. So say you have a second temperature reading something like this. And if you were to compile this, it'll still be the same because PGFPlots uses the first 2 columns, and you can change that by specifying y equals temperature 2, temp2 in our case. So there you go. You can also perform math operations. So in this case, let's say I wanted to add 20 to my third column when I plot it for the y-axis. In that case, you would use the command this row, and then I'd like to add 20 to it. So it's giving me an error here, and that's because I've specified it to be y, which is not so this whole expression is not a header, it's not present in the header, and the keyword that you require to use is y expression, or y space expr. And there you go, it's shifted the temperature 2 reading upwards by 20 like I desire. Now these are super simple curves, and oftentimes the tabulated data that you have is going to contain several hundreds or even thousands of data points. In that case, it does not make sense to copy the data from your CSV file or some program that outputs it into your LaTeX document like this. In that case, you would be reading the table from your CSV file into LaTeX. And the command that you used for that is PGFPlots table read. So let's go ahead and use that here. So that's PGFPlots table read, that file name, let's call it mydata.csv, and a tag associated with that data set. So in this case, I'll call it my table. Now I haven't created this file inside my folder, so let's use the same data set to create a CSV file. So I've called it mydata.csv, and let's add that data set. PGFPlots is usually not too worried about these leading spaces, but let's just clean up that table and go back to the main document here. So now mydata.csv has the required tabulated data set, and I can use what's inside there using this label. So I can say my table over here instead of the data set. Now for PGFPlots table read to work properly, you require the package PGFPlots table. So let's also import that. And let's try running it. So LaTeX angry at me. Let's take out all these extra spaces just to make sure that's not what is causing the errors. And there you go. Now LaTeX is happy. And the reason for that is when I have a space over here, it does not read the command correctly. So no spaces. And you can use every concept that we talked about earlier on in this session inside the options or inside the expression, and change the data accordingly. And that's the end of this session. Hopefully you've gained a basic understanding of how to draw figures and illustration inside LaTeX using the packages TikZ and PGFPlots. Thank you.